Let's talk about some possible number sentences that you may have gotten in the last video. 5 times 7 is 35. 10 plus 10 plus 10 plus 5, which would be going off of the 10 frames, a group of 10, a group of 10, and 5 more. 5 plus 5 plus 5 plus 5 plus 5 is 35, etc. Think back to how Alfonso figured out how many circles there were. Use Alfonso's same strategy here to find out how many tiles are needed. Write a number sentence with Alfonso's reasoning. Think back to how Jennifer figured out how many circles there were. Use Jennifer's same strategy here to find out how many tiles are needed. Write a number sentence with Jennifer's reasoning. Pause the video, see if you can flip back, take a stab at it, and then we'll reveal the answer. So Alfonso found 25 shaded tiles and 10 white tiles, so 35 tiles in all. So he did 5 by 5 for the shaded, and he did a 5 by 2 for the unshaded, and got total of 35. Whereas Jennifer found the total of 35 tiles in all by taking a 5 by 7. Print the attached homework in the measurement and data Dropbox. Complete the set of worksheets and scan and upload them back into the Dropbox. Another piece of your homework. There are many ways to find the area of this figure, and we're going to use decomposition to help us with that. So try to find as many ways as you can to split this figure into exactly 3 rectangles. Be sure that none of the rectangles overlap and the 3 rectangles cover the entire figure. Sketch each deconstruction you create, and for every deconstruction you create from part A, write an expression that represents the area as the sum of these 3 rectangles, just as Alfonso did. Find the total area of the figure, and then part D, scan and upload your answers to the rectangles discussion board. Then take a moment to see what other ideas your classmates have. Comment if you wish, but not required. What is the greatest area you can make with a rectangle that has a perimeter of 24 units? What are the possible dimensions of a rectangle that has a perimeter of 24 units? And how can we determine their area? Take a moment, pause, jot some ideas down, and then we'll come back together. One possibility would be 8 plus 8 plus 4 plus 4 to get 24 units for our perimeter, and that the area would be 8 by 4, so 32 square units. We could also do a 10 by 2, so 10 plus 10 plus 2 plus 2 is 24 units for our perimeter, and our area would be 10 by 2, which is 20 square units. This one is much smaller than the first one, so far we do have a larger one, but is it the largest possible? We could have done 1 plus 1 plus 11 plus 11 for 24 units, which would be a 1 by 11. Man, we're getting smaller. This is only 11 square units. We could do a 6 by 6, which is 6 plus 6 plus 6 plus 6, which is 24 units. And the area would be a 6 by 6, so 36 square units. When I compare all the square unit options, I see that this is the largest. So a square gives us the greatest area in this particular instance. Geometry. This one is very much smaller than measurement and data, but equally as important as we continue to talk about shapes and their attributes and partitioning those shapes. For your homework for geometry, flexagons are paper models that can be flexed to reveal hidden faces. They were originally created by a Princeton student in 1939 and became super popular when Martin Gardner published about them many years later. So you're going to create your own flexagon called a kaleidocycle because ours are going to be 3D. Watch the video on flexagons and how to make your own flexagon on the Flexagon discussion board. Print the flexagon template, create a fun design, perhaps even do this with a friend, your child or children, neighbor kids, anybody that you want to do it with. They're fun and unique, and it'd be fun to create them together. Cut paste as directed in the video. Take a photo or video and share with your classmates back in the Flexagon discussion. I look forward to seeing your creations. For each of the pictures, explain how you can see that half of the square is shaded. Take a moment to see if you can't figure this out on your own by pausing the video. Let's look at the first one. I see that if I were to cut my square in half, I'd have two rectangles. I also notice that if I were to cut the diagonals in half, that exactly half of each rectangle is shaded. So therefore, half of the square is shaded. Moving to the middle one, if I cross-cut vertically and horizontally straight down the middle, I see that exactly half of each partitioned area is shaded, so therefore the whole thing would have to be half shaded. The last one's a little more tricky, but if I cut down my center or fold in my center, one idea would be to see that if I were to take the circles and cut out the black circle and the white circle and interchange them, they would be the exact same size, so I would have half black and half white, so therefore half is shaded. For each of the pictures, decide whether one half of the circle is shaded or not. Explain how you know. Again, pause the video, take a stab at this, and see how you do. Looking at the first circle, if I were to cut down the middle, I would be able to take that black triangle that's kind of cut off there, and I would be able to easily fit it into this open white area, so therefore exactly half is covered. However, the second one, if I were to imagine moving these two unshaded pieces together, I can see that they're not going to fill up half the circle. So therefore, more than half must be shaded. And that's great when we compare the third one, because notice that if we were to cut them vertically and horizontally, that there is exactly the same amount of shaded as unshaded, whereas these ones, the black parts are just a little bit more than these here. And then finally, the last one, the small shaded piece on the left is the same size as the unshaded piece on the right. So I imagine that these two pieces trade places, and therefore we would have equal amounts of shaded and unshaded. Next week, we are going to finish third grade. It has its own special week because we are finally going to introduce fractions and how to work with fractions. And I just feel that it's important we take a whole week on fractions. This is really where we develop a solid foundation of fractions, and they're important for students so that they're comfortable moving forward. So we'll see you next week.